For RCR Wireless News, I'm Sean Kinney, and we've got a great interview for you today with Doug Thornton, Technical Director with Battelle. We'll get into all the details, but Battelle is bringing to market a really interesting open, ultra-wideband massive MIMO radio unit called RavenStar. So Doug, thanks for joining me. Looking forward to the conversation.
Thanks. I'm looking forward to talking about it, Sean, and reaching out to your audience.
So I want to dig into the work Battelle is doing with RavenStar, but before we get into that, maybe you could share a bit of background on the organization as a whole and how you think about leveraging your strength in innovation and R&D to commercialize new technologies like RavenStar.
So Battelle is a nonprofit charity, effectively, with the mission of translating scientific discovery and scientific advances to societal benefit. And what that means is we try to take emergent technologies and concepts, oftentimes coming out of academia, but other places, and do what we need to do to make them real and get them into the marketplace. So with that, we've done a few things that you may be familiar with. There's Xerox, so the whole concept of dry photocopying was not initiated at Battelle. That was by a guy named Chester Carlton, but it was refined and turned into a viable commercial product that was then taken by the Hallowed Corporation and turned into the Xerox company. So that's one example. Another couple examples are compact disc, fully sputtered photovoltaic, so solar panels, things like that, where there is a longer term need for investment and you need diverse teams. And what Battelle provides is that diversity of teams, the people who can be brought together to solve a problem for the first time, or look at a problem differently for a first time. And that's what we're doing here on RavenStar, is we are bringing a diverse set of teams to look at some of these telecommunication problems a little bit differently than what industry has had before.
Now, Doug, can you take us through some of the key features of the radio and help us understand how you're differentiating this product from other solutions that are in the market?
Right. So RavenStar, which I've got two particular units behind me here. Obviously, I'm in our anechoic chamber because it was a great place to record a video because it's nice and quiet. Although the RF doesn't come in from Wi-Fi very well in here. So what we do in here is we measure and characterize our arrays over space. So RavenStar is at its core an array technology. So lots of antennas working together. And Battelle has been nurturing that over about 10 years. And what we had done is we looked at some of those features that we were developing for non-commercial applications and started to talk to commercial industry about how they would be useful, or if they would be useful to them, and started investing in that. And then ultimately that led to the Public Wireless Supply Chain Innovation Fund grant that we had recently received to really accelerate that commercialization process. So at its foundation, inside of there is a 64 element array, and we actually, on the one behind me here, is a 128 element array. And the technology at its basis are, you can think of them as little apertures instead of little resonant antenna elements. So they work with the electric fields going through them versus operating with the electrical fields going around them. And that enables us to put more antennas in a smaller space. It also makes them wideband. So this particular unit here has been tested across the whole FR1 spectrum. So we've done commercial testing on the TDD bands that show that. We've also done other FDD testing with it as well. With this particular unit, for size, weight, performance, cost trade-offs, we decided to focus on band 77, where band 77 is a very, very large band, but having flexibility to do that. So we can put a lot of antennas in a small space and make them wideband. So now you can do multi-band deployments in the same size and physical footprint. So there's lots of reasons that is good, but it is also good from a sense that we don't have to redesign an aperture per application. The other factor that comes into play when you start putting lots of antenna elements together is you get a better ability to create beams. So these beams can be higher fidelity. So the narrowness of your beam is defined by physics. So when we make a small aperture, obviously this is a pretty small device over here. You can only make a beam so small, but what we can do with more elements is we can put more nulls. So as you get into your densification deployment scenarios where it's mostly interference limited rather than signal limited, that allows you to put nulls. It allows you to handle multipath much better. So that's the fundamental technology is how we have brought that high density aperture into a highly manufacturable environment. So the apertures coming together in here will be assembled in 3 minutes. This is all on standard machines. There's no machines that a normal production house wouldn't have that are required to put one of these systems together versus something that needs to have any hand touch labor or special equipment to solder and make physical elements 3 dimensions.
With RavenStar, you're targeting mobile network operators and the federal sector. So for MNOs, you seem really well aligned with two big trends. That's the move to Open RAN and the densification we typically see in the second half of a 10-year G cycle, so 5G in this case. Open RAN, also a big priority for the US government, which is going through a significant digital transformation as well. Maybe just take us through it all.
So yeah, I'd like to discuss Open RAN first because that's really why we are here. Without Open RAN, Battelle wouldn't even try to innovate in this market. So radio is hard. Radio work is hard. It involves many different talents and expertises and disciplines coming together to do it. So what Open RAN has provided to us is these specifications that allow us to innovate with known interfaces. Without Open RAN, we're starting with an antenna. We see its opportunity, but how do we fit that within an ecosystem? And Open RAN guided us to say, okay, if you make a ORU, it will fit in the ecosystem, and then you can start to show that innovation because people have to see it. It has to be real. PowerPoints will only get you so far as you're explaining the value of a technology. So Open RAN has enabled that for us, and we see it's going to enable a whole lot of the industry that's like us that could provide innovation, but hasn't had the doors open to them at this point. So with that, we've been focused on using our radio unit to aid in the densification. There's a lot of good reasons for that. As we took our wideband aperture, started talking to network operators, infrastructure providers, the key feedback that we got was the value in consolidating infrastructure. Sometimes it's the cost of the infrastructure itself. Sometimes it's the cost and time of permitting processes. And they said, if you can do the job of multiple radios in one radio, where that really matters is when you have space limitations or you have optic limitations where people don't want to see the radios or they want to see them in a particular form factor. But that also meshes well with us and our technology. Being a array that can do the massive MIMO functions, the coherent beamforming, the nulling interference, that densification is that next step where we will see lots of benefits to the arrays. Many of today's massive MIMO deployments are macro cells on towers where they're using mostly C-band to create very strong beams, improve your signal quality because of antenna gain. So there is a lot of multipath mitigation, interference mitigation going on to those macro cells. But as you get into that densification layer, where you're down in the mix, you have all the reflectors around you. You're much closer to the user equipment. It's just much higher interference, and we see that as an area where massive MIMO hasn't really made it yet, and we want to see a lot of the benefit. So today's CAN when you see a right away deployment, usually there's some sort of CAN antenna, so a CAN with multiple antenna bands, and then a couple radios stacked behind it. If we can get those to be arrays, your spectral efficiency is going to go way up. But to do that, you also have to conserve the space claim, so that it either make it smaller than it is now or keep it the same size. Otherwise, the permits are going to get hard hit. So on the MNO side, that's where we've seen the open door is targeting that densification. And then for Battelle being a new entrant with Open RAN, that densification, there's a more of a risk tolerance in that area because you're providing your baseline services with your macro cells on your coverage layer. You don't want that to fail. People have their lives and health depend on that communication system. Densification layer is more of just providing additional capacity, those additional features. So we've had a lot of success looking into that densification layer, and then grow into that macro layer at a later time when the market has seen us as not a new entrant carrying some risks as a new entrant, but as an established entity that has reliable equipment. From a federal standpoint, the Department of Defense is really looking to 5G systems to do two things. They have a lot of different types of communication systems that are proprietary and therefore expensive. When you go to a 3GPP based system, you get a lot of cost benefit because a lot of research dollars go into that. A lot of economies of scale come there. But then they aren't necessarily trusted systems because they're consumer systems. They're not designed for the specific security and some of your shock, your vibe, your environmentals, the things that the military needs. On another aspect of those DoD systems is they're trying to do a digital transformation. So if we can move data amongst our bases, amongst our equipment, how can we use that to create more efficient logistics operations? Like the Army has more trucks than anybody else in the world. They're a huge logistics entity. So how do you digitally transform that in a cost-efficient manner? So with the defense market, there's a couple entries here. One, we are a domestic supplier who knows how to do business with the Department of Defense. So we can have full supply chain provenance and software, bill of material, understanding of what we are handing over and delivering. It's made in the United States by our team that's all throughout the country. That's one benefit, is that ability to apply the security and do so with a trusted entity that knows how to meet the requirements of the government. Another is that we can focus on being a smaller company. Because we're starting from zero, if we sell 1,000 radios, that's 1,000 more than we sold last year. So that's great. Your big incumbents that are servicing the tier 1 MNOs, that's not enough to get their machine moving in that direction. So they know how to do radios. They know how to make them efficient. They know how to do them very well. It's just serving a different type of market with different needs. So we can come in and serve their needs. So that includes operating in the Department of Defense's spectrum. It also means spectrum relocation, depending on where they're deploying, as well as meeting some of their different requirements. And they probably don't need 320 watt macro cells as much as they need a bunch of little 40 watt micro cells. And that's what we've been focusing on.
To date, a lot of the discourse and technical work on Open RAN has been around interoperability, just proving out that different combinations of hardware and software can work together and show parity or even surpass it in terms of performance, power, price compared to integrated RAN. Tell us about the interoperability work you've done and any details you can share around field trials.
Yeah. Thanks, Sean. That's a great point. That right now, Open RAN is exiting this can it work phase, and then we're moving on to a prove the value proposition phase. So now that it works, we need to actually show the realization of the value proposition that has been promised by Open RAN. For us doing arrays, We're still at the tail end of the can of work. Systems up to 4T4 are definitely in the value proposition proving phase now. So as we move out, we're going to keep adding maturity to our systems. So the way Battelle has approached this problem, there are a number of things that have helped us accelerate that. So first, we have the NTIA through the Public Wireless Supply Chain Innovation Fund doing the smart thing. And the first thing they invested in was infrastructure for us to test with. So what we've done with our unit over here is we've taken it out to the Valor Laboratory, which was a NOFO 1 award twice, to do some conformance testing and early interoperability testing to get that. Additionally, we've partnered with VT Arc, who has integrated it with a open source base station software called SRS RAN. So they did that out in Blacksburg, Virginia, for a multi-band test. We then also did a field experiment with that back end out in near Tucson, Arizona, at a field site that was really just desert. And we had established a seismic array out there and needed to bring data off of that array back to commercial internet. So we used a RavenStar to bring that data across. That was a long duration out in the sun field trial with that particular radio on the back end. And then we have also done integration and interoperability with GXC's enterprise solutions. The other field experiments that we've done, we've been out to Iceland and did some outdoor to indoor band 41 testing out there as a part of just a systems demonstration. And then we recently got a program experimental license from the FCC. So Battelle has a 1,000-acre site out in central Ohio where we can now stand up these networks and do field experiments. We've done a number out there. Our field exercises to date, as a part of our NOFO 2 funding, we are doing integration with Radisys and then following that up with Rakuten Symphony. And that will get us to those true commercial deployment type networks.
I really like your characterization of this first phase of Open RAN as, can we make it work? So now we seem to be entering a second phase, which is about making the most of the architecture. To me, that means reaping the benefits of an intelligent, programmable radio access network. You know, we're still in the early days of deploying the RAN intelligent controller and fairly nascent XApp, RApp space. But what do you see, Doug, as the big long-term benefits of Open RAN?
Yeah, thanks. That's a great point. Like I said earlier, we wouldn't be here without Open RAN. So that's one shift. And 2 years ago, or even a year and a half ago, if you were to ask anybody at one of these conferences, oh, what's Battelle doing in the radio world? Very few people would know. And that's because we were able to use and leverage Open RAN quietly to start building up and de-risking our own internal developments. And you don't know how many people are doing that right now with their XApps and other tools that they just want to sit back and make sure that they're ready before they start putting a public face on. So first thing I see, there's this, it's a technical solution, but it provides a industry transformation. So if you want to innovate in cellular prior to Open RAN, you are tied towards these consolidating vendors who honestly, they have different priorities. They have to make their stuff work. They need to deliver to their customers. They know what their customers need. And then that misses a whole set of emerging customers. So what I've seen so far with people coming out of the unexpected places, there are a lot of spectrum owners right now that aren't on 3GPP systems. And Open RAN is going to open up the market for them to start thinking about deploying in 3GPP versus some other technology or an exquisite solution. So some of those, your energy your logistics, transportation. A lot of those areas are not the market that your typical tier one providers are looking at, but could be satisfied by Open RAN. So there's going to be a whole market opening. And as you see network in a box solutions start to come available, it would be great to see RavenStar included in one of these. You go to a website and you buy network in a box, and now you start deploying it or taking it to your laboratory and innovating an X app or an R app on it. That's one area of innovation. The second area, like you described the X app and the R apps as being, as a part of the RIC, being a key driver to this next phase of Open RAN. And that is 100% true from our perspective, because to get the full flexibility out of a RavenStar unit like this, you're going to need to combine it. So we'll have to deliver it with an X app or an R app for the network to utilize those features. So an array like this, so you have to think about how a network operator would deploy it with the right amount of complexity. You don't want to give them the entirety of the flexibility of, okay, steer every channel and sort it all out and optimize the system. They're used to deploying a 4T4R system. So how do you start out by making it look like a 4T4R system and then leverage in some controllability? It's like, okay, so now you have a 4T4R system that plugs into your network as is, but you can now change it from being a 120-degree sector to a 90-degree sector at the speed of software. That's all going to be X apps. You can also say, oh, I'm getting a lot of interference. I just need to block out that other tower. Now you can start nulling a beam in that area. We're going to see a whole lot of software-defined network functionality enabled by the combination of arrays and the ability for people to deliver into those scenarios fast and efficient. And the number of scenarios that are going to be handled is just going to exponentially increase, because people can start deploying networks affordably and experiment with them. So as a institute or a commercial entity, you're going to soon have the choice of, do I want a Wi-Fi network or do I want a 5G network or 3GPP if we're starting to talk about 6G? And right now, that's a pretty easy solution until you do your network modeling and like, oh, my factory needs 100 access points. You're going to see that transition being enabled to move over to those others, and that's going to spawn a whole lot of innovation for those more niche capabilities. But then we're going to see the mobile network operators want to take up some of that innovation that has been de-risked and put in the field and proven, and move those into the broader market.
You referenced this earlier, but I wanted to unpack it a little bit more. If I look at the past 30 years, the trend among radio vendors is towards consolidation. It's a scale business with a high barrier to entry. That said, what you're doing here in terms of supporting a huge addressable market with one SKU seems like something that could change those historical dynamics. Big picture, what are your expectations for RavenStar as you ramp up your go-to-market?
Yeah, so industry has consolidated. That's where we get to the need for Open RAN to begin with, is to help work within that consolidation in some ways. But it consolidated because it had to. Radio frequency, it's hard. And if you look at all the disciplines it takes interoperating together to deliver a functional system, and then you have to do that with respect to each nation's specific requirements. You have each mobile network operator's specific frequency allocations, and then you have things like multi-band systems. So it became very, very difficult to keep delivering. So you have to leverage consistencies between your products, because if you look at a product that would be a tier one serving the entire world, you have 2,000 plus radio SKUs just to service that major MNO market. And ITU and other entities are trying to consolidate, but there's also the need for more and more spectrum. So anywhere there is spectrum, 3GPP will define it and try to use it and make those work. So yeah, you've had that drive to consolidation just because of the challenge, the scope, and the scale of the problem. But what we see as Battelle is the opportunity to start looking at that problem differently. And instead of designing one radio for one frequency, designing a radio that can operate at multiple frequencies, and then you can deploy it however you need to see fit. So by having a multi-band antenna, multi-band electronics behind it, now you have a significant number of less SKUs. So maybe each individual part would increase in cost if you were to look at it on a per unit basis. But as you look at it across a product portfolio, you get a lot greater economies of scale. If you reuse a product or part 10 times, you get 10x the volume buys. So that drives efficiency, and it's pricing pressure on that part, but also your supply chain of bringing that part in, leveraging it, testing it, and then deploying it. It all becomes simple. So that's one of the things that we've designed into our systems to date is a modularity, where it's going to be the same digital card that goes in each system. Then that goes to a application, a analog front end that could be tuned to different types of applications, but those are swaths of applications instead of one network operator's frequency band. And then you have an antenna that you're not redesigning each time. So in the grand scheme of things, we're making a general purpose radio unit in a field where everything else is application specific. So that always has trade-offs to it. So maybe, so what we would say is, if you're going to design a radio very specifically for an application, you can always make it very good. You can always get the best performance. To go to something more general, you will be making trade-offs. But if you look at your computer, it's full of general purpose hardware that can be reprogrammed and reused. So even though I can make a calculator a whole lot more power efficient and faster if it's just being a calculator, but using your computer as a calculator has many other benefits. And that's where we see RavenStar taking the industry, is being able to leverage that lower number of SKUs to have a simpler supply chain and simpler delivery chain, but also open up software definition of the network and optimizing your network at an infrastructure scale, but also do so dynamically. So that way you can respond to changes in your consumer base, the network needs, network demands, but also things like price of electricity. The networks being a huge electricity consumer, RavenStar system being a highly dense array, we can turn off 25% of that array and still function quite well. But we just reduce that power, so you can start responding to markets and other needs outside of the way people typically look at those networks.
It's an innovative piece of technology. Battelle has a great track record of translating R&D into commercial success, so I'm really excited to see what you're able to do with RavenStar. Doug, thank you so much for joining me to share your perspective with our audience.
And thanks for having me here today, Sean.